Hi there, I'm Pete. I'm at Peter J. West on Twitter. I'm going to be kind of doing a sort of intro talk to TypeScript, so aimed at people who maybe have just heard of it or have never heard of it or have maybe just started with it. If you know TypeScript quite well, you'll probably be quite bored, but maybe you can give me some pointers afterwards about things I got wrong, anything I can improve. So what I'm going to do is go through some of the theoretical basics of TypeScript, and then go through practical steps you can do to get TypeScript running on your existing projects. Because while it's quite nice to have this on kind of your new projects, I think the most use will come from being able to sort of put it into existing projects. And there'll be some kind of gotchas along the way. There's quite a lot of things that aren't really very well documented or sort of legacy. So we'll kind of try and catch some of those on the way. So what is TypeScript? It's kind of in the name. It adds strong typing to JavaScript, and it compiles to JavaScript. I like to say, it complements the sort of open and malleable design principles of JavaScript. So it lets you do a lot, by letting you do whatever the hell you want. It lets you do a lot, but you can also kind of screw things up by abusing it. It's got a pretty steep learning curve. I'd say it takes a couple of months of using it to really get to grips with all of the things you'll need to be able to do. But once you get there, you get quite a lot of benefits to your code quality and preventing bugs and things. So the other thing about it is it has no effect to your JavaScript. If you convert your project from JavaScript to TypeScript, the code you have online will be nearly, if not entirely, identical. There's really nothing left once it's compiled. So the compiler basically checks that your types make sense, that all your code works correctly, and then it just removes all of TypeScript. That's the compilation process, is deleting TypeScript. So why would you care? We've been using no types or no, dynamic, loose typing in JavaScript for years, and everything's fine. So yeah, improves your robustness, kind of gets rid of, stops bugs before they happen. If you've got a nice editor, they'll show up in the editor before you even save the file. It's kind of, you can think of the types as being the kind of the glue between your different components. So it'll ensure some kind of integrity between them all. The other thing is it kind of does a bit of self-documentation. If anyone's ever used doc blocks or been forced to use them, basically if you write a doc block and then turn away and turn back, it will be out of date, because there's just no incentive to keep things in date, to keep things synchronized, unless you've got tools to do that as well. But this basically means you can't compile your code unless the types are up to date. And the other thing I found, which is quite interesting, is it really improves your understanding of the language as you write. So you end up knowing more about the code you're writing, whereas before I'd be quite fuzzy on exactly what a function was doing and what it was returning. Now I have to know, because I have to know in order to write the types. So taking a basic example in JavaScript. So this is a thing that takes an array of strings and basically just counts all of them. It's not a great function, but it's taking an array of strings and counting all the letters in all the strings and adding them all up. And in JavaScript, we've got some hints as to what these things are. If I didn't explain that to you, you'd look at this and go, okay, well, words is used in a for loop, so it must be some kind of iterable thing, and we're checking the length property of it, so it must be something with a length property, so probably a string or another list. And we know that that's going to return a number. So moving on, the TypeScript example of this is that. So the only thing that's changed is we've added the colon string square brackets. So what this does is just told TypeScript the type of that argument is going to be an array of strings. Everything else about this function, so this function is now fully specified in TypeScript. Everything else all the other variables TypeScript has inferred, and type inference is kind of a big deal in TypeScript. It's a fairly big part of the language and why it's good. So TypeScript knows this count needs to be a number because it's you've set it to 0. It knows that word is a string because words is an array of strings. It knows that length is a number because strings have a property called length, which is a number. And it knows the return type is a number. So all of this is inferred. If we didn't want to rely on that inference, if we wanted to be more explicit, you can, oh yeah, sorry, missed a bit. If you've got an editor like VS Code, you can hover over count letters and you will get the complete type of the function. So you can see TypeScript knows that the return type is a number. But yeah, if we didn't want to rely on that inference, we can specify the return type here after the arguments. And we can specify the type of the count variable as well. So there's kind of two approaches. You can go with the minimal or the maximal. And that's kind of bringing me to, should you use it? I don't think there is an obvious answer. It's in certain strongly typed languages, it's kind of a hotly debated question of how much type inference is good. So yeah, it makes your code easier to write, a bit shorter, maybe a bit less explicit. And if you're using sort of this method, then it may have a bit of a reliance on your IDE, on your editor to show you the inferred value if you want to know that. Personally, I think it's really nice. My entire team use VS Code, so we've all got the TypeScript plugin. So we don't really mind having stuff being implicit and kind of getting it from the editor. But I don't think there is a one answer to this. Okay, so I'm going to move on to some primitive types now. They're all pretty obvious. Yeah, you got numbers, strings, booleans, null, undefined. As we saw in the previous example, all of these are strictly redundant. So if you didn't put any of these in, TypeScript would guess the type. If you give it a number, it'll guess the type is number. If you give it a boolean, it'll guess the type is boolean. Yeah, these are all pretty straightforward. Then we've got object types. So arrays were also in the previous example. So if you want an array of something, you put square brackets after it, and that's the type as an array. TypeScript kind of expects all arrays to have all the same type within them, although you can get around that. But with this syntax, it kind of expects there to be an array of one particular type of thing. TypeScript has a bit of a different approach to JavaScript for objects. So in JavaScript, objects are whatever you want them to be. Add, random properties at any point you want. You could make a class and instantiate it and then add a property to it. But in TypeScript, it expects you to either use objects in kind of object instance mode, where they have specified properties. So in this case, we've got A and B specified as a number and a string, or have it in dictionary mode, if anyone's, there's a term from Python, which is basically you can have any number of values and keys in this, but they all have to have the same value, which in this case is a number. So we can have A, B, C in that one. So it's a bit of a limitation. You can technically combine these two, but in general, I find it works best to kind of have an object which is a dictionary where you put anything into it, or an object which is more like an instance where you know exactly what the keys are and they don't ever change. Evil types. So this is a bit of an initial gotcha for TypeScript. The docs generally don't tell you about these, so don't use any of these. Number, string, and boolean are all referring to the type, the primitive constructors you can use. So if you use new boolean, you will get a boolean object which is not a boolean. And so if you did new boolean with false as an argument, you will get a boolean object which is true. So use basically just lowercase these and you'll be fine, and don't ever do new boolean, new string. That's not the way to do it. With object and function as sort of keyword types, object basically just means this is a type of something that inherits from object. It basically is not telling TypeScript anything useful about it other than it's an object, and it's the same with function. So in all these cases, you would be better off just removing the type definition, and you would get a more accurate type. Okay, so TypeScript adds 2 new statements you can use to specify more complex types. It's adding interface. So interface works a bit like a class definition. So if you're using ES6 classes, this will be quite familiar. You specify your interface name, you specify any properties and methods you want on it, and you can then use this foo keyword as a type anywhere you want. There's also the type statement, which is, so this one's a bit like classes, this one's a bit like conventional code. So you just say bar equals some other type. So in this case, we basically just named this type as bar. And it's a bit of a fake out because both of these types we've created, foo and bar, are both interfaces and types. It's just a sort of syntactic difference at this point, because they're both, any type which is for an object is an interface as well. So these are equivalent. You could use either of them you could swap the syntax around on these and it would work fine. So with interfaces, you can extend them like classes. So if I have a base interface which has a property, I can use make another one and then extend it. And the child interface will contain both of them. And then what we can do with this is we can say, one of the things we can do is take that child interface and put it at the end of a class definition saying it implements this type. Implements this interface, which means your class will be required to have all the things specified in here. Type statements, so yeah, define it a bit like just assignment there. You can also do this to alias types, so we can have child equals base if we just wanted to rename a type to use it in a different place. What else have we got? Okay, let's do it. Another thing is with types, you can export them and import them like you would with anything else, but they do share the same namespace as all of your other exports and imports. Some people do like I before all of their interface, all of their types to sort of distinguish them so they're in a separate namespace. So we can do some more cool stuff with combining types. So unions, so pipe operator gives us a union, which basically means either this or that. So in this case, we've got a character list, which we're defining as a number, array of numbers, or as a string. Yeah, string is basically an array of numbers in a sense. And so as an example, I could make a thing that is a truncate function, which is going to sort of shorten something, and I can tell it to take character list as an input. And you can see that TypeScript is kind of, in my editor, is already showing me an error here, because it knows that although, which one is it? String has the method substr, an array of numbers doesn't have that method. So this isn't good right now. So we can change that to slice, because we know that arrays and strings have both got the slice method, so now it's all good. But there's a bit more of a problem. Is if we can't easily do this, we need to be able to discriminate between the two types. So this is called decomposing unions. So if we have something which is a string or a number, we need to be able to know to special case that into strings and into numbers so that we can treat them differently. So if we want to take more than one type into a function, we need to be able to break them down afterwards. And that's where TypeScript really works nicely with JavaScript. So what it's doing here is TypeScript knows about the type of operator. So it knows that if you do type of value equals number in a if block, then anything inside this, the value inside this must be a number. It also knows that because the if block returns, the return value here must be a string. So if we were to, I haven't got a slide for it, but if we were to hover over format data, it would know that format data returns a string, because to fix returns a string, and the value here is definitely a string. So this is where the sort of inference stuff gets kind of clever. And yeah, TypeScript's got lots of nice things where it integrates well with the language to figure out stuff. So intersections, these are kind of the complement to unions. So this is and instead of or. Basically just lets you combine two types. So this is equivalent, have I put this? Yeah, this is equivalent to our inheritance. We can do multiple inheritance in TypeScript. It just sort of inherits them in order. So we can kind of combine stuff together in either way. And again, both of these are still interfaces, so you could use them in any way you'd use interfaces. Optionals. So in JavaScript, it gets a bit kind of vague with function arguments. You sort of define a whole bunch of them and then use some of them some of the time. In TypeScript, it gets a bit upset if you use like more or less than a specified. So if you do want to have ones that you're not going to always add in, you'll need to use optional. So that's a question mark there. And that just means that you may not specify that. So it also means that the type is implicitly whatever type it is or undefined. So it's kind of nice in that it adds it directly into the type. So we now know this function may or may not take the end argument, and the dog may or may not contain a bone. Hopefully the dog contains some bones, but hold a bone? Yeah. So yeah, this will be undefined, which kind of brings us to null and undefined. So if we look at the dog bone example, if we had a dog object that has a name, because you have to name your dog, but then the bone, it may not exist. So if you haven't set that key, it's already going to be undefined. So it's actually a lot more convenient in TypeScript to use undefined over null, because you'll see undefines all the time. And whereas in JavaScript you can be quite like wishy-washy over it, like it's a null or undefined, who cares? In TypeScript it starts to become like a real hassle to try and like manage all your nulls and undefines. And if you just use undefined, it's kind of easier. So yeah, it occurs naturally in implicit returns, unset properties, and optional arguments. So it kind of is natural. If you did still want to use null, it's completely fine. You just have to put all null in a lot more places. And yeah, it works as normal. Okay, so generics, yeah. If people know types already, generics are kind of an obvious thing. If you don't, then they're kind of confusing. So basically what we've done so far is stuff to do with like basic primitive types, which generally works quite well. But when you come to work with utility functions you want to use in multiple places on multiple different things, you start having to like rewrite them multiple times to have all the different types. Generics are a way to kind of say, well, this utility function can take an array of anything, but it's still an array of something typed. If we have a cat, we can specify cat to be an array of cat. We had this before with cat angle brackets. This is kind of a syntactic sugar for arrays. But in general, array itself is a generic type that takes another type that goes inside it. So you can think of generic types as sort of specifying what's going inside the thing. Oh yeah, we've also got a promise. So if anyone's using promises, a promise is a type which you have to specify the return type, so the value that's going to be resolved in that promise. So promise.resolve true, we're expecting to get a Boolean back. This is pretty like key if you do want to actually use promises and have TypeScript with promises as well. So generic function, maybe hopefully a slightly easier example. If you have a function filter value, it's going to filter and keep only the values in an array which match a value you provide it. Not terribly useful, but this could easily be turned into something a bit more useful. What we do is we specify in angle brackets before the arguments one or more generic types. And now, so type is kind of like a function argument. It doesn't exist anywhere yet. It's just we've named it that because it's a convenient way to name it. And then we're saying our array must be that type, but an array, and our value must be that type. And then if we you call this function, we then provide that generic type, which we're going to say is going to be a number. And now TypeScript is going to check that the arguments match the generic type. So it's just kind of like checking everything out. And we don't even need to put in the generic type because TypeScript is sort of smart enough to look through the arguments that have been provided and tell you if they're going to make sense, basically. So at this point now, TypeScript knows that the return value is going to be an array of strings here, an array of numbers here. Oh yeah, so that was probably the most complicated part of TypeScript I'm going to go through. These bits do get a bit more involved. Some of the stuff is a bit crazy, but in general, it doesn't get much more complex than that. So TypeScript you don't just have to work with TypeScript modules, so you can import JavaScript modules. The problem with this is that your JavaScript modules don't have types, or TypeScript can't necessarily tell everything it needs to about them. So someone's come up with a way of kind of adding types into your modules like this. So there's this @types library. So if you want to install a library, so we've got the Bluebird promise library, then if we also install @types/Bluebird, you'll get type definitions along with it. And what that means is that TypeScript will know what the hell's going on. So when you start using Bluebird, it'll say, okay, well, this is this type, this is this, and it all kind of works together. Some downsides of this is that these don't always exist. These aren't always maintained by the same authors. Some authors are like, no, I don't want to do that, TypeScript sucks. So sometimes these are out of date, sometimes these don't exist. Some of the bigger libraries have got the types built into the libraries themselves. You don't need the @types. So yeah, this is a little bit less than perfect right now. Okay, so that's all theory. Hopefully not too boring. What I wanted to do for the rest of this talk is kind of just go through how would you if you wanted to get started with TypeScript, how would you do that? And I'm going to split this into sections of what's the minimum you need to do to use TypeScript right now. Like the easy mode could work. You could do this in, I don't know, a day on most repositories. It's mostly just going through and doing quite manual steps. Later on, there's sort of steps for actually making TypeScript really work for you. But the biggest hurdle is actually taking a JavaScript project and getting it running in TypeScript. So this is my patented guide for getting your project into TypeScript. So you need to have TypeScript installed. It doesn't need to be global, but that's the easiest way. You need a tsconfig file, and we'll go through what needs to go in there. You need to install your @type packages. You don't need to actually, but you may as well go through and try and install as many of those as you can. And you rename all your files to TS, and then you go through a loop of fixing stuff. So basically try to compile with TSC. You need to sort of point it at the right folder for what you want to compile to. But in general, it will just take TypeScript files, output them to another folder as JavaScript files. And the JavaScript should be fairly readable. It's mainly taking stuff out. And yeah, fix stuff until it compiles. And I'll go through some of the things that are kind of common problems when you try and do that. Oh yeah, so start with tsconfig. So these are I've picked some of the most confusing terms out of tsconfig. A lot of them, I mean, we all use tons of config files for various things in web these days, but a lot of them make a lot of sense. These are the ones that make the least sense. So module, Module is the export and import style that it's going to output. So if you're using ES5 style, you want common.js. I think it's ES6 if you want the sort of import default, export default type styles. Module resolution, this should always be Node, never change it. The other option is legacy, and it's just there to confuse you. Target is the version of JavaScript to target, but it's not doing polyfilling, it's not doing most things. It's basically it's doing syntactic sort of sugar changes. So I'm not sure on the exact list, but it'll do some stuff, but it's not polyfilling. This is not going to give you something that's suitable for web. Lib, so this is kind of specifying different libraries that you have available on your environment. But again, it's not doing any polyfilling. All this is doing is defining what types are available for those. An annoying one is they don't support Node in here, so you have to do the Node types in a different way. Okay, so I've got a module that I've just turned into a TypeScript file, and I've got some common problems that happen with this one. So we got some red messages. These two are because we don't have our types for Node, I just mentioned. So if we install the types for Node and save that, then they'll be fixed. These two are probably the most weird and torturous part of TypeScript, which is TypeScript tries to guess if you are using Node code or like web code, and it does that by looking for a ES6 style export or import, and if you don't have any, so you've just got this ES5 export, it will interpret this script as global. So actually it's complaining about left pad because I have left pad in another file in my project. So to fix that, we need to convert our ES5 export into an ES6 export, and then it's happy. Oh yeah, I want to do a bit of an aside just for anyone who's not moved on to kind of ES6 style imports and exports. So if we have a variable which we want to export to another module, so left-hand side is common.js, right-hand side is ES6. We would have done exports equals, and then hello equals require to get it back again. So this is the export, this is the import. In ES6, there is no way to do the first one, and the second one really exists just for sort of backwards compatibility so that you can use old style projects. ES6 has named exports, so you can export something with a certain name, and that's pretty much equivalent to doing this in ES5, and these are sort of cross-compatible. ES6 has the new default export, so you can, it's like the main thing you're exporting, which sort of replaces this, and you do that via the exports.default key in ES5. So this is basically identical to TypeScript. TypeScript uses the ES6, I mean. However, TypeScript does add one additional way of doing exports. So the one which has no equivalent in ES6, in TypeScript we do have an equivalent. So we have export equals, which is slightly different, but basically it does the same as module.exports equals hello. And I suspect this is because TypeScript has to support older versions of JavaScript, so they kind of wanted to make that possible. Another gotcha, require does not support types. So if you're still using require, you'll get stuff back. It will work, but it won't have any types associated with it. And that's because you can't, because require takes a string, you can't statically analyze the types of it. You don't know what thing is going to be required. Yeah, it just doesn't work very well for that. Okay. So another common gotcha I came across in my kind of testing for this is reuse variables. So if you reuse a variable, TypeScript will have specified a single type for it, and you'll be you'll be trying to redefine that and it won't like it, so you just rename it. Another common gotcha is if you're using ES5 style classes, so this is like constructor function and then we add a static method onto that later on. This is how sort of before the nice new class syntax came in, we were sort of incrementally building up our classes. TypeScript doesn't like this because when you defined this class, this function, it implicitly guessed the type and it guessed that as just being a raw function. So it's not expecting this and now it's like, grr. The easiest way to fix this is to move over to ES6 classes. So then the whole thing is declared in one single block and we don't have to worry about sort of incremental structures. Another one is in your JavaScript code, you may well have like default parameters which you've set. So if count wasn't set, we set it to 1. And so talk is going to meow 3 times and talk with no argument is going to meow once. But TypeScript is unhappy about this. And that's because it's expecting one argument here because we've specified one argument. So we can actually add an optional type there, which means we are optionally expecting that parameter, and now it's happy. And TypeScript actually goes a bit further because it's got default arguments. I'm not sure if that's an ES6 feature as well, but it's certainly in TypeScript. So you can just say count equals 1, and that will work the same. So count equals 1 is the same as the setting it to an optional type with number. Okay. So for easy mode, we've also got a cheat code, which is any. Any is basically the type that tells TypeScript to just go away. So if you set something to any, TypeScript will kind of ignore anything it does until it comes back to not being an any type. So yeah, any, ignore a variable and anything derived from it. It's really good for beginners, and it was really good when I was starting out because you can just go, I have to get this like thing released, and I can't be bothered with this type nonsense. And you just go any. And then later you can come back and figure out what's actually going on. So we can actually go back through all the previous examples and just cheat. So let's see. We had this problem. We just put cat : any. Now it's an any. Don't care. Value. Put value : any. Now it doesn't care. So we can use that. If you want to get a project into TypeScript, you can use any to fix all the problems until you want to come back and fix them later, because I mean, it was a kind of a long process from us moving to TypeScript before we were actually getting rid of all of these. Okay, so improving your types. So the first section was how can you get your project into TypeScript. Second section is how can we actually get rid of those bad types and make it stricter so you actually get stuff out of it. If you just stay back in this mode, you won't get a huge amount out of TypeScript. So improving. Basically, tsconfig settings, set these to true. I'll go through them all one by one, but these are all good things. They will take work in your code base to make them compile, but they're definitely worth getting through. Always strict basically means that it's going to, when it compiles your code, it's just going to put you strict in there. It's pretty good. Strict property initialization. I can't remember what this is. Okay, so basically checks that you write to a property before you use it. So if you said you're going to have a property and it's going to be a string, you need to, in your, say if it's in an object, in a class, you need to set that somewhere before you try and access it. And that's actually fairly intelligent, so it knows if you put something in your constructor, it knows that's going to run before anything outside of your constructor. Strict null checks, yeah. If you don't have this, it will kind of let you use null or undefined in kind of as an any. In fact, you should probably turn this on as soon as you can because it stops a lot of horrible cases. So I mentioned any is great. Now we've gone to the next level. Any is not great. Any is really bad. So what we need to do is get rid of any. So, for example, this cat thing looks fine. It's a TypeScript thingy, and then we go and when we go and look at all of the types of everything, and we've got all of these any's everywhere. Basically, by default, TypeScript will have implicit any's where if you don't specify it, it'll guess any. And if you can't guess anything better. So generally function arguments will, I think, always be any if you don't specify them. So if we turn on no implicit any, you're suddenly going to get about 1 million errors of all the places where it's not specified. I'd suggest as a first step for this is you go and you manually put in any on all of those. It's still not perfect, but it means you then have, you can do a grep for all of the any's in your repository, and you know how bad your types are, basically. So untyped variables will become explicit and findable. The other problem you'll get with turning on that rule is that third-party modules will start being problems. When you import them, they're going to show, kind of have errors on them. So what you can do is you can add this to your tsconfig, which is type roots, add a .types folder, and then put this file in your .types folder, and you can start declaring modules just empty. And if you declare a module empty like this, then you're basically saying, I'm okay with all of the types in this cucumber library being any. Just stop complaining. So this means you can kind of get an audit trail of all the libraries you're using that don't have types, but they won't bother you. That mode is kind of is kind of an iterative cycle of gradually improving your types, removing any's, adding proper structured types in. You want to be using types and interfaces to get rid of duplication in your types. So you don't really want to be specifying like string or number or something all the time. Name the types and share them, export them, and share them between modules. Final section. One thing you can start doing when you've gotten everything else out of the way is you can start declaring modules, but not just leaving them empty. So we can declare a module and put stuff in it. So this is an example library called glob get ignore that I use at work, and it doesn't have types, so we define the types we need. And this isn't perfect. We've got like an any there, but it's kind of good enough to do what we need to do. I'm also pretty sure this library's got more functions and things in it, but this is the only one we use. So you can sort of define your own types. You can also contribute. So the @types thing I showed earlier, that's this library, definitely typed, and it contains all of the types for every npm, well, every TypeScript module or JavaScript module that has types, which is about like 1,000. So if you load it in GitHub, it kind of crashes the page. Well, certainly for a while. But those are sort of two ways you can do it. Another thing is that your external sources might not do the thing that you're expecting. Because TypeScript gets removed at compile time, by runtime, there's nothing to stop the wrong data coming in. So if you make an API call and you've said to TypeScript, yeah, API call, and it's going to return like an array of strings, the API call might return whatever the hell it wants. So you don't know, you don't have safety here. So if you want to be sort of truly type safe and have real confidence that your code's going to work, you need to have some kind of validation. And then you need a way to keep the validation in sync with your TypeScript types. So it's really annoying, but kind of unavoidable. I don't know of any really cool libraries that kind of merge these together nicely yet. Another one is typecasting. I haven't really covered this yet, but it's a thing you can do. So in other languages, typecasting is kind of a good thing. As far as I could see in TypeScript, it's mainly a way to lie to the compiler. So if we have a cat here, cat has to have a name, and then we make a thing that's definitely not a cat, doesn't have a name, and then we can make a new variable and do this as cat, which is our typecast. So we're just saying to TypeScript, yep, it's definitely a cat, trust me. So that's not going to work. Your code here will be happily compiling and letting you do stuff with the name property, expecting it to be a string, but you could easily run into problems. Like if you try to do string.length on an undefined because there's no name, you're going to crash your program. And like this is what happens if you try and typecast to a cat. One way to do typecasting that's sort of fairly responsible. So if we're using React and using JSX, then you might have this input element, and we want to set an on-click event. So the types that you get here with your event will be a generic event, and the target will be a generic HTML element. So it's got no idea what kind of HTML element, but we want to get to the value property because we know it's an input box and we want to know what the value is. So to do this, we can cast to HTML input element because we know as responsible developers this is attached to an input field, input element. So we know that's going to work. So that's one way to kind of do that nicely. The other thing, I wanted to give a quick shout out to a library called tsnode, which is really cool for using TypeScript. Basically, it is you normally install it globally. You run it like Node, except you give it a TypeScript file instead of a JavaScript file. You can also call tsnode and just use the, what's it called? REPL, yeah. You can just use the REPL to run TypeScript on the command line, which is really nice. So this is really great and means you don't have to have a whole compile step to use scripts. So at my company, we're using all of our scripts run in TypeScript, and this is kind of really nice for that because you don't have to go through a whole compile step to change them and run them again. And that's everything I have. I'm working at DiffBlue in Oxford. Kind of cringy subtitle. But yeah, we're looking for full stack developers if anyone's interested in moving to Oxford. And we use a number of things: TypeScript, React, Node, Mongo, Docker. That's about like half of them. We do loads of stuff. And yeah, talk to me if you're interested. And that's it. Slide link there.